Now, in this row 7, the assignment for x1, x2 and x3, the assignment for x1, x2, x3 is assignment for x1, x2 and x3 is 0, 0 and 1. That means x1 takes the value 0, x2 takes the value 0 and also x3 takes the value x3 takes the value 1. And the corresponding value of the Boolean expression alpha is 1. Okay. So what would be the mean term for this row 7, for this assignment 0, 0, 1? Let us now see that very. Look at this. The value of x1 is 0, the value of x2 is 0. So we shall take in the mean term, that means in the product term, x1 complement into x2 complement. The value of x3 being 1, we shall write into x3. That means what we have written here? We have written, or we have taken x1 complement into x2 complement into x3 as the mean term for this assignment 0, 0, 1 for this 7th row. I have written here that very. For row 6, this is for row 7, x1 complement. For row 7, alpha 4 of x1, x2, x3 equal to x1 complement into x2 complement into x3 complement. And particularly for this assignment, we shall have the value of this alpha 4 is equal to 1 only when we shall consider the values of x1, x2 and x3 respectively 0, 0 and 1. Elsewhere the value of this alpha 4 Boolean expression is 0. Similarly, for this row 6, we shall have to take the mean term as x1 complement into x2 into x3 complement. Okay, and I have written here that very. Alpha 3 of x1, x2, x3, this is equal to x1 complement into x2 into x3 complement. Similarly, for this row 8, the values of x1, x2 and x3 being 0, 0 and 0, we shall have to take the mean term for this corresponding assignment for this row 8 as x1 complement into x2 complement into x3 complement. Okay, and I have written here that very. Alpha 5 of x1, x2, x3, this is equal to x1 complement into x2 complement into x3 complement. Okay. Now, for the corresponding row, for the specific assignment of x1, x2 and x3, the values are 1, and for any other assignment, the value is equal to 0. I have written here the very line. Okay. So each of alpha 1, alpha 2, alpha 3, alpha 4 and alpha 5, of course their mean terms being the product of x1 tilde, x2 into x2 tilde and x3 tilde. Tilde means either x1 or x1 complement, x2 tilde means either x2 or x2 complement, and x3 tilde means either x3 or x3 complement. Okay, and here we are considering an Boolean expression. Here we are considering an Boolean expression which is beta, and that is equal to alpha 1 plus alpha 2 plus alpha 3 plus alpha 4 plus alpha 5. That means the sum of all mean terms which we have written for this assignment table, of the Boolean expression alpha. We have taken the sum of all these mean terms, of all the very mean terms, and we have written the mean terms corresponding to those very rows for which the value of the original Boolean expression alpha which there has been given is equal to 1. Okay, and we are considering beta equal to alpha 1 plus alpha 2 plus alpha 3 plus alpha 4 plus alpha 5. Alpha 1 is a mean term, alpha 2 is a mean term, alpha 3 is a mean term, alpha 4 is a mean term, and also alpha 5 is a mean term. And these mean terms we have written here from this corresponding assignment table of alpha for the corresponding rows for which the value of the expression, original Boolean expression alpha is equal to 1. These are the mean terms, and being the sum of the mean terms, and obviously this is in DNF form. This beta is in DNF form, and this is a Boolean expression beta. Now we shall have to check whether this beta is equal to the original Boolean expression alpha or not. To check that very what we have to do, we have to consider the very assignment table for alpha and beta, and we have to check whether for each and every assignment the corresponding values of the Boolean expression alpha and this Boolean expression beta are equal or not. If they are equal, then we shall call that alpha equal to beta, otherwise they are not equal. So let us now check the very assignment, the very corresponding values of alpha and beta from the assignment table. Okay.